Good morning, students. In our last class, you all remember that we have done up to Rutherford's model. We were discussing regarding atoms. In atoms, we have done up to the Rutherford's model. Rutherford's model we have seen, just as a backup, I tell you, in Rutherford's model we have seen that the different aspects of atoms have been discussed there. Regarding nucleus also we have got a lot of informations and size of the nucleus and all, and ultimately we have seen that there are some limitations. There are some limitations of Rutherford's model, right? Keeping in mind these limitations, although Rutherford's model is very much informative, right, but it is suffering from limitations. Keeping in mind those limitations of Rutherford's model, Bohr's theory or Bohr's model was proposed. Bohr's theory or Bohr's model was proposed. Alright, so today we are going to discuss the Bohr's theory. But before that, once I recapitulate that in case of the Rutherford's model we have seen the limitations, main limitation was that the electron revolves around the nucleus in all the orbits of the different radii. Actually, what happened there, that when an accelerating electron is continuously revolving, then it radiates out the energy, right, due to which it is revolving in the orbits having smaller and smaller radii following a spiral path. That was the main limitations. So keeping in mind those limitations, let us discuss today Bohr's theory. Okay, actually Niels Bohr was the physicist who has proposed this Bohr's theory. What are the first, before I proceed in this Bohr's theory, let us first discuss some important postulates. Let us discuss some important postulates of Bohr's theory. What are the important postulates of Bohr's theory? Let us see that. So, important postulates. Number one. As discussed in the Rutherford's model, here also we shall repeat the same thing. That is, there is a nucleus in the central part of the atom, in which all the positive charge of the atom is concentrated in the nucleus, and around that nucleus electrons revolve, so that the electrostatic force, just make a note of it, so that the electrostatic force exerted by the nucleus on the electrons, revolving electrons, provides the electrons the necessary centripetal force. I think you must be remembering this thing we have seen in Bohr's theory also. Second point, unlike Rutherford's model, electrons do not revolve in any orbit, but they revolve in some specific orbits. Right? So electrons do not revolve in any orbit, but they revolve in some specific orbits where the angular momentum of the electron is quantized. That means these are the orbits in which the angular momentum of the electrons is quantized. That means angular momentum of the electron is quantized, means mvr is equal to nh by twice pi. I write this equation 1. I hope, dear students, you remember in class 11 we have done rotational motion. You have studied rotational motion, and you know that mv into r is the angular momentum that is quantized here in h by 2 pi. Here n is equal to 1, 2, 3, 4 and so on. It is called principal quantum number. It is called principal quantum number. That means it represents the order number of the orbits. The innermost orbit is N1 and outermost orbit, as we go, N will be 2, 3, 4 and so on. Then number 3, the third. Here, while electrons revolve in the permitted orbits, that means these orbits where the angular momentum is quantized, these are called permitted orbits. When electrons revolve in the permitted orbits, so when electrons revolve in the permitted orbits, what happens there? It do not radiate any energy. The problem of the Rutherford's model has been sorted out. It does not radiate any energy. So while revolving in the permitted orbits, electrons do not radiate out any energy. Okay, so electrons do not radiate out any energy. So these orbits are called or known as the stationary orbits. These orbits are known as stationary orbits. Alright? Orbits. And now number fourth. Electrons radiate energy only or absorb energy when electrons jump from higher orbit to lower orbit or vice versa. That means when electrons jump from higher orbit to lower orbit like this, suppose this is the nucleus, electrons are just for understanding point of view, suppose it is jumping from higher orbit to lower orbit, means outer to inner, then what happens? The emission of radiation takes place. Higher to lower orbit, emission of radiation takes place. And obviously, if it jumps from lower to higher orbit, then the absorption of radiation will take place. That means emission or absorption will be taking place only if the electrons jumps from one orbit to another orbit, maybe from outer to inner or vice versa. These are some important postulates, very important Bohr's postulates. If you are asked to discuss, to say regarding Bohr's postulates, these are the Bohr's postulates. Fine. Now, after Bohr's postulates, now we want to discuss this Bohr's theory. In our syllabus, mainly we have to discuss it for the hydrogen atom. So let us now discuss Bohr's theory for the hydrogen atom. Alright, in case of the hydrogen atom. So what I do here, I just remove this. Here also I remove this. Let this be here. Bohr's theory, I write here for hydrogen atom. Let us now discuss Bohr's theory for hydrogen atom. Now, see, you know, in a hydrogen atom, there is one proton, and here, this is the orbit. Here is the orbit in the central part. Here, electron is revolving. Suppose the electron is revolving with the speed v, and m is the mass of the electron, and this is the orbital radius. You know, here R is known as the orbital. It is called orbital radius. Look, small r is the orbital radius. Electron is revolving around this here. Obviously, its charge is plus E, this charge is minus E. Because in hydrogen, only one proton, one electron. So plus E in the central core, in the nucleus, and minus E, that is for the electron. When the electron, now what will happen if the electron revolves around this, and how the different parts can be discussed. Okay, so in the next lecture I will continue that.